Today, I am going to discuss about the topic enzyme-linked immunosorbent assay. Enzyme-linked immunosorbent assay, or simply it is called ELISA, is a very sensitive immunological technique. And this particular technique is used to access the presence of specific protein in the form of antigen or antibody in the given sample and to quantify it. Means the presence of antigen or antibody, how much amount, what it should be the concentration of these specific proteins present in the provided sample. This particular technique is also called solid phase enzyme immunoassay, as it employs an enzyme linked antigen or antibody as a marker for the detection of specific protein. The enzyme should be conjugated with an antibody that is actually reacting with the substrate, which is generally colorless substrate, to generate a chromogen, means a colored end product. A number of enzymes have been employed for this particular purpose. That includes alkaline phosphatase, horseradish peroxidase, beta galactosidase, like that. And in 1971, this particular technique was introduced by Peter Parlman and Eva Engvall at Stockholm University in Sweden. So it is a common laboratory technique, or pathological laboratory mostly use this particular type of technique, which is usually used to measure the concentration of antibodies or the antigen present in the patient sample, mostly patient blood sample. Now, the question is, why should we term it as ELISA? So ELISA, this term has come from the first letter of enzyme-linked immunosorbent assay. So E comes from enzyme, L from linked, I from immuno, S from sorbent, and A from assay. Here, antigen of interest first absorbed to the plastic surface of the polystyrene coated plate. It is the microtiter plate or the 96-well plate, and this is known as sorbent. Then the antigen is recognized by a specific primary antibody, and the reaction is immune type. So henceforth it is called immuno. Next step is that another antibody, that is a secondary antibody, can recognize the primary antibody, and this secondary antibody, which is linked with or tagged with an enzyme. That is why the term enzyme linked has come. And the last is the substrate that is specific towards the enzyme, that reacts with the enzyme to produce a colored end product. So that is why ELISA, the term, has come. Now I'm coming to the principle of ELISA. So as I said, that ELISA is a plate-based assay. That is why it is also known as solid phase enzyme immunoassay, which is typically performed in a 96-well polystyrene plate and quantifying substances such as protein, antibody, hormone, antigens, like that. So an enzyme conjugated with an antibody reacts with a colorless substrate to generate a colored end product. Such substrate is called a chromogenic substrate. And a number of enzymes have been used in ELISA, such as alkaline phosphatase, horseradish peroxidase, beta galactosidase, like that. And specific substrate such as orthophenyldiamine dihydrochloride for peroxidase, and then para-nitrophenyl phosphate for alkaline phosphatase, mostly use which has hydrolyzed by the enzymes to give a colored end product. And this colored end product is measurable as a it is measurable as a function or quantity of antigen or antibody present in a given sample. And by quantifying the intensity of the color or optical density measured at 450 nanometer, we can quantify the intensity, or we can quantify the color that gives an indication of the amount of antigen or antibody present in the provided blood sample. Next is there are two type of ELISA. One is known as quantitative ELISA, another one is the qualitative ELISA. So performing a qualitative ELISA, we can only detect whether the particulars or the specific protein what we are looking for is present in the provided sample or not. So presence or absence can be detected. So this particular type of ELISA is known as qualitative ELISA. Whereas on the other hand, if you want to try if you want to quantify, means how much concentrated your sample antigen is, then definitely you have to go for quantitative ELISA technique. In that particular technique, you can quantify the antigen or the antibody by determining the titer. So the titer is nothing but the highest dilution of the specimen, usually the serum, so which gives a positive reaction in the particular test. So that highest dilution should be considered as the titer value for that particular specimen. Now, this by just by simply comparing with the data, with a table already provided to all of the laboratories, they can compare it and they can detect the load of sample or load of parasite present in the patient sample. So to perform this particular process, we have to follow 4 different steps. So the first step is that we have to load the sample, means the antigen what we are looking for, into the microtiter wells. So when we are pouring say 50 to 25 to 50 microliter of antigen solution or the patient sample, so if the antigen is present there, because it is unknown to us whether it is present or absent, we don't know. So if the antigen is present there, it will absorb to the inner surface of the 96 well plate. So we have to allow 5 to 10 minutes for that, and then we will rinse it to remove the unbound antigens or unbound sample. Next step is that we have to add a specific antibody that will function as a primary antibody towards that antigen. We will add sufficient amount of antibody and allow it to react at least for 5 minutes, and then again we will rinse it to remove the excess unbound antibody. Next step is that we will add secondary antibody tagged with any of the enzymes I have already discussed, and again we will allow to react between the two antibodies. We have to keep the plate undisturbed for at least 5 minutes. Then again we will go for washing, and then at the last step we will add the specific substrate, as a substrate that is specific towards the enzyme. So after incubation of 5 to 10 minutes, we will again first we will use the blocking buffer to stop the reaction, and then we will use the washing buffer maybe once or twice to get the unbound fraction out, and then we will quantify this, or we will check it either via a naked eye, or else we can go for check it into an ELISA plate reader. So this is all about the steps or procedures of ELISA. Now, what are the materials we need for this particular process? So first step is that we need some test sample or specimen. So what are the sources of specimen? Where from we can get antigen or antibody? the specific protein we are looking for. So the sample may be serum in the form of blood, cerebrospinal fluid, sputum, urine, semen, or else the supernatant of culture, as well as stool. So these will serve as a sample, a specimen for ELISA testing. Next, we need two different types of antibody. In most of the cases, once we need only single antibody, that is the primary antibody. And here, if we are using two different type of antibody, then the primary antibody will be intact or unlabeled, the secondary antibody will be labeled. And if we are using the one type of antibody, then definitely we have to use a primary antibody that should be tagged with the enzyme. Next is that we need a matrix where we can perform or carry on the experiment, and that matrix is a polystyrene microtiter plate or 96 well plate. The two buffers we need, one for washing or rinsing the microtiter plate wells, and the other one is the blocking buffer to stop the reaction. So other two is that enzyme that that should be provided tagged with either the secondary antibody or the primary antibody, or maybe with the antigen, and a substrate specific towards the enzyme. So here the enzymes, 3 or 4 type of enzymes can be used. Mostly we use phosphatase peroxidase. Unless that, we can use alkaline phosphatase, beta galactosidase, lacto peroxidase. We can also use for this. Now there are 4 different types of ELISA. One is direct ELISA, indirect ELISA, sandwich ELISA, and competitive ELISA. In case of direct ELISA, first we are putting the microtiter plate using the unknown sample, or better to say using antigen. Then we are adding, in case of direct ELISA, we are adding the antibody, primary antibody tagged with an enzyme. So the primary antibody will interact with the antigen, and we are adding the substrate directly and allowing it to react at least for 5 minutes, keeping the plate undisturbed. Then we are adding the blocking buffer, and if you look for the intensity check, you will see that at the lowest concentration of the antigen, the peak is very low, but at highest concentration of antigen, the peak is very high, means the intensity is very high. This graph will show you that result. Now I am coming to another type of ELISA, that is indirect ELISA. Here we are not adding the antibody tagged with enzyme, but at the antigen coated microtiter plate well, we are adding the primary antibody that is untagged, and then we are adding the secondary antibody, but it is the secondary antibody that is tagged with an enzyme. So the secondary antibody has specificity towards the primary antibody, and then we are adding the substrate, allowing it to interact, allowing it means 5 minutes incubation time should be provided. Then we are adding the blocking buffer, rinsing it, stopping the reactions, and then we are again going for checking. So when we will check, then here we will get the similar type of data pattern. Means at the lowest concentration of antigen, the intensity or the absorption will be on the lower side, but at highest concentration of antigen it will be on the higher side. Next is sandwich ELISA. So what we are doing here, we are not adding the antigen to coat the plate. Instead of that, we are adding primary antibody to coat the plate. Then we are adding antigen to interact with, specifically with the primary antibody. And after that, we are adding the secondary antibody tagged with an enzyme. Then we are adding the substrate and allowing it to interact. 5 minutes incubation time should be provided, and then we are going for check after adding the blocking buffer to stop the reaction. Then we will see similar type of data pattern, means lowest concentration of antigen will show low absorption, and highest concentration of antigen will show high absorption. But here we are using the sandwich ELISA because The sandwich ELISA has some advantages rather than the indirect or the direct ELISA. So what are the advantages sandwich ELISA is provided? The advantage is that this particular technique means sandwich ELISA technique. This is highly specific. Since two antibodies are used, the antigen is specifically captured and detected. It's not that less amount of antigen that is not identified by the antibody. So mostly in case of complex sample, since the antigen doesn't require purification prior to measurement, we can use the sandwich ELISA process. And due to having the flexibility as well as the highest sensitivity, this type of ELISA method can be used ahead of direct or indirect ELISA technique. The last one is competitive ELISA technique, and this competitive ELISA technique is a different one. So far whatever we have discussed, it is totally different. So here we are adding first the antibody, primary antibody, to coat the polystyrene plate well, and then we are adding two types of antigen. One antigen that is unknown to us, untagged, and one antigen that has the specificity towards the antibody, and this particular antibody is tagged with an enzyme, and a known concentration of the tagged antigen will be added to interact with the antibody along with the untagged unknown antigen. And here we can get two different type of reaction. So we have mixed both the unknown as well as the known tagged enzyme level antigen to interact with the primary antibody. We are not using here secondary antibody like the direct ELISA technique. So here there will be competition between the untagged antigen and the tagged antigen, because both have similar both have same specificity or similar specificity towards the antibody. But in that case, if the tagged antibody has more specificity, then it will bound more with the antibody and form complex rather than the untagged or unknown antigen. So on that case, we will get the maximum amount of intensity. So here you can see that this graph is just the reverse one. So at the lowest concentration of untagged antigen, so the absorption peak is much or maximum, or at the highest concentration or highest binding of antigen, untagged antigen or unknown antigen to the antibody, the absorption will be the minimum. So this result will show us that there is a competition between the two types of antigen, and that is why we are getting this type of data. So now the last part, that is how to interpret data. So this is the microtiter plate where we can perform ELISA technique. But here, simply by naked eye, you can identify whether the reaction is positive or not, whether the reaction has taken place or not, or whether the chromosome has formed or not. But if you want to quantify, then you have to measure the color of the chromosome produced after interaction between the enzyme and the substrate. And here the wavelength you have to select is 450 nanometer. And you have to check or detect the sample and analyze the sample under a particular instrument that is known as ELISA plate reader. So there you will get different absorption value, and you have to calculate, you have to analyze the absorption value with the other two type of data set, that is the positive and negative control, and one should be assay control. So most of the cases we are using positive and negative control and the sample. So positive control and the negative control will show us the reaction is uh, is happening. There is no such problem in the reagent, only to confirm that. And then if say here you can see here there are three different patient samples to be assessed. And now this particular assay, if we are getting this type of data, means patient C have similar density, optical density with the positive one, then definitely we can say the patient C and patient B, they are positive. But here the severity or the presence of or the concentration of antigen is present more in patient C rather than in patient B, but patient A it is almost negative because here the OD value or the absorption value of patient A is almost similar to that of negative control. So we can say that patient A is negative, patient B and patient C are positive, but the titer value will be more in case of patient C. So presence of antigen is more in case of patient C. So here through this you can identify the concentration of antigen present at the patient sample, and you can also quantify it. And if the patient sample contains the antigen or antibody at the concentration range nanogram to per ml to picogram per ml, this technique is that much of have that much of sensitivity that it can assess at that lowest concentration also. So that's all for today.